Hi friends, welcome to Engineering Clinic. Today we are going to see synchronous data flow modeling in Ptolemy II. It is one kind of modeling tool in cyber physical system. This is what we are going to deal with it today.
There is no time dependencies, then it is static. So that means actors can produce as well as consume. Firing or execution of actors are triggered by tokens at the ports. Okay, so that's what on synchronous data flow that we have already discussed in the last session. So today we'll be seeing some mathematical models of this synchronous data flow. So let's consider. So please be attentive on this because it is a modeling here. So unless you understand the mathematical model, you may not understand the full concept of it. Okay, so if you read the book directly, I don't know whether how well you will be getting it. So that's why please listen to the lecture so that you can understand in a better way. So assume there are two actors A, B. Okay, so they have tokens M and N. So A, B are actors. A and B are actors. M and N are tokens. Okay, so M and N are tokens. So that means the condition here is when A is fired, M tokens are generated. When A is fired, M tokens are generated, or we call it as produced at the output port. Produced at the output port. Then when B is fired or executed. So we call B is fired or executed. Then N tokens are consumed by B. Consumed by B. Okay. So M is the number of tokens generated when the actor A is executed or fired, and N is the number of tokens consumed by the actor B when it is fired. Okay. So when A is fired and when B is fired, then N tokens are consumed. Here M tokens are produced. So producer consumer problem. We call it as producer consumer. It's a problem. Okay. Now, having said this, so the tokens are being generated when particular actors are fired. The tokens are consumed when particular actors are fired. Okay. Now, how many times a token can be generated? How many times it can be fired? So that is another statement here. How many times the execution happens? Okay. So let's assume QA be number of times A is fired. How many times it is fired? So that is QA. QB is number of times B is fired. Number of times B is fired. So that is what QB. Okay. So all the tokens of A that A produces are consumed by B if and only if. So the syntax here is all the tokens produced by A are consumed by B if and only if. That's a double if and only if QA into M equal to QB into N. Okay, so please remember this formula. So all the tokens produced by actor A are consumed by actor B if and only if. So this means that if and only if and only if QA into M equal to QB into N, where M is the number of tokens generated at A and N is the number of tokens consumed at B when B is fired. QA is the number of times the actor is fired. QB is number of times the actor B is fired. So this condition should satisfy when both are executed. Okay, so that is what this QA into M into QA into M. Okay, now one example we will see. Example we will see. So in the example, it is given as M equals 2 and N equals 3. M equals 2 and N equals 3. Okay. So now to balance this equation, so QA into 2 equal to QB into 3. Okay. So both should be equal. So QA and QB should be equal. So there could be multiple options available for QA and QB. The starting option would be if QA equal to 3, then QB should be 2. The reason being 3 into 2 equal to 2 into 3. So that's why 6 equal to 6. So both get satisfied. So that means QA equal to 3 and QB equal to 2. What does it mean? So QA will be A fires 3 times and B fires 2 times. B fires 2 times. Okay. So that's what it means. So B cannot fire before A fires because the B is depending on A as per this diagram. As per this diagram, whatever A gives, that is what B is consuming. Whatever A produces, that's what B is consuming. So in that case, B has to fire, only A has to fire it. So the choice could be like this: A, and A. Okay. So this way, once A is there, A, then I can have B and B. So this firing can be happen. So first time A is firing, second time A fires, third time A fires. So the 3 times over. Afterwards, B is firing. B is firing means B is consuming what A is producing. Okay. So in that case, B is firing twice. Okay. The same case we can have this way also. A fires 2 times. Then after 2 times, it is sufficient for handling B. So B fires once. But B has to fire 2 times. But A already fired 2 times. B can be fired 2 times. So in that case, if I put B here, then if I put A here, then there is no need for producing this object. Okay. So there is no producing of this token is not needed here because B is already completed its consuming job it has to complete. So A should not come here. So in that case, this is wrong. So in that case, I have to go like this. A has to consume twice, then B, then one more time A will be producing, then B will be consuming. So this will be consuming, this will be consuming. So this way, these tokens are been the firing and the tokens have been generated. So this will be in the buffer. This will be in the buffer of A. So at any point of time, the actor can have a buffer. So in the buffer, the data will be stored. Okay. So that is the concept of this synchronous data flow. So synchronous data flow means, so when one actor is producing, the other actor will be receiving that particular thing. So in the applications, what we have seen so far, in the last class, we have seen the audio application, audio capture. When I was talking to the mic and when I was whistling in the mic, it is capturing. The spectrum is firing only once. The spectrum is firing only once, but the order of the spectrum is 2 power 8. So totally 256 times the spectrum is firing. But the spectrum fired only once, but the all other components like audio capture, the choppers, and all other signals, they are firing the number of times the spectrum is being fired. The spectrum fired only once, but they were firing for 256 times because the order of the spectrum is 2 power 8. So in that case, the spectrum is a consumer, which whatever this audio capture is producing, the spectrum is consuming. So that is how the way the producer consumer problem in this synchronous data flow happens. Okay. So in this case, we have A, B here. So 3 times A is producing and 2 times B is consuming. So the job of the thing is done, and one of the A is in buffer because it is unused. Because B is firing only twice, so the third thing produced by A will not be consumed by B because it will be in the buffer. Similarly, here in this case, A, B, B, and A. So this is wrong because finally this A is not been consumed. So here in this case, this A be consumed and this A be consumed. This A is in the buffer. So this way we can able to program a SDF. So synchronous data flow. Okay. Other way around, if the same thing happen here, the same example here, QA into 3 equal to QB QA into 2. QA into 2 equal to QB. The other way around is we can use QA equal to 6, then QB equal to 4. So this is also possible. So that means 6 into 2 equal to 4 into 3. So both are 12, equal to 12. So in that case, 6 and this will be 4. So now what happens? 6 is A 6 times. After that, B. So B consume 4 times. Or else we can have A. Then we'll have B. Then we have A. So this may not be because this 2A has been producing lately. So in that case, we'll have A. Then we'll have B. Then again we'll have A. Then B. And we'll have another A. So here also this A is being getting wasted here. So then what we have to do is A, B, then AA, then B. In that case, these two A will be in the buffer. Sorry. So these two A will be in the buffer. So likewise, the synchronous data flow I can able to do as per my liking. I can able. So this example is called as balancing equation. Okay. So now another example we'll see. Example 2. Example 2. Let me take the problem. So let's say QA equals QB. Then 2QB equals QC. Then 2QA equals QC. Okay. So we have a logic like this. So we have three actors A, B, C. Among that QA equals QB and 2QB equals QC and 2QA equals QC. Okay. Now to solve for this equation, so QA equal to QB. So then what we have to do is 2QB plus 2QB equal to 2QC. 2QC. So when I add both, so that means 4QB equal to 2QC. Okay. So that means 2QB equal to QC we are getting, and QA, QC here. Now what would be the value of QA, QB, QC here? So what would be the value? So it's a QA equal to QB, 2QB equal to QC, and 2QA equal to QC. In that case, what is QA, what is QB, and what is QC? What could be QC? Can you find out using by solving the equation? Anyone, please? Hello, could you hear me?
Yes, sir.
Yeah. Okay. So now let me see QA equal to QB. So if we put QA and 1 and QB and 1, then QC will be 2. So QA equal to 1, QB equal to 1, and QC equal to 2. Now this will be valid. QA, QB equal to this one. and 2 QB, 2 into 1 equal to 2, and here also 2 into 1 equal to 2. Okay, so now in that case, so what I have is I have actor A, then I have actor B, then I have actor C. Now from A to B, I have 1 and 1 because QA equal to QB, I have 1 here. From B to C, 2 QB equal to C. That means 2 times when B is fired, C will be fired once. Similarly, when A to C, even A is fired twice, C is firing once. Okay, so C firing 2 times, one for B, another for A. So this is a consistent SDF model, consistent SDF flow, data flow, or we call SDF model. Now, as per this value, when QA equal to QB, so when QA equal to QB means, so it has both input and the output port will be 1 and 1. Then 2 QA equal to QC and 2 QB equal to QC. So in that case, here this informs that 2 QC equal to QB. Okay, now here it will be 2 QA equal to QC. Okay, so as per the balancing equation. So what is the balancing equation? We can say when A and C are two actors. So like this, A here and here it is C here and here it is 2 1. Then what is the number of tokens here? So then obviously you will have M into QA into M equal to QB into N. So now in this case we have QC here. Now QC. So number of things here is 2 QA equal to, here it is N is QC. So that's what 2 QA equal to QC. So as per this balancing equation. So whatever A is producing, C has to consume. So now this is the equation for that. So this way, based on the values what we allocate for the number of times an actor is being fired, we can able to compute their relationship. Okay. Now SDF also has feedback. SDF also has feedback. So feedback in the sense that how we can able to analyze feedback is, again we'll go with one example of feedback. Okay, so now we have A, then we have B. So A and B is connected. So A with 3 and B with 2. That is the tokens. Then I have 1, 2, 3 and 4. So this is my feedback. Okay, so this is my feedback. So since it is 3 here, the B is consuming 2, so it produces also 2. And A is producing 3, so it should consume also 3. Okay, so now this is my token. So this is this I call as the initial token. Initial token. Okay, now this is the feedback. Okay, now in this case, A and B are actors. A and B are actors. So initial tokens by feedback loop. Okay. Now A and B, how many times it fires and how many tokens it produces? So A produces 3 tokens and consumes 3 tokens. Similarly, B produces 2 tokens and consumes 2 tokens. Okay, so A produces 3 tokens and consumes 3 tokens, and B produces 2 tokens and consumes 2 tokens. Okay, now you just think, now what I do is, please listen to this diagram here. Now A produces 3 tokens. So when this feedback is fired, when A is fired, it produces 3 tokens. Okay. Now it needs 3 input before A is being triggered. 3. So already we have 4 here, 4 initial tokens. So 4 dots indicates 4 tokens, but we need only 3. Okay, so now in the second case, we have only 1 token remaining. So the 3 tokens are here, 1, 2, 3. So 3 tokens. So 3 will be generated here. So 3 will be generated. And B needs only 2 tokens to consume. So B needs only 2 tokens. So the 2 tokens will be consumed here. So then 1 token will be in the queue. So 1 token will be in the buffer. Okay. So 1 token will be in the buffer. And it produces two tokens. So it produces 2 tokens. B produces 2 tokens. But out of 3 in the B consumes only 2. But remaining one is already here as the remaining 1 token. Okay. Now B produces 2 tokens. Now these 2 comes here. 1 and 2. These 2 comes here. Okay, when these 2 comes, already we have 1 here, 1, 2 and 3. Totally 3 tokens now. Now in the feedback we have 3 tokens. Now these 3 tokens move here. Now come back here. Now again 3 tokens. So when again for the next time firing 3 tokens, again A generate 3 tokens. Now A generate 3 tokens. Now A generate 3 tokens. Already we have this one in the buffer. This one in the buffers plus 3 tokens. 1, 2, 3. So that means in the first one it is already free here because the earlier iteration only 2 tokens are consumed. 1 token is left as it is. So now we have 4 tokens. So 4 tokens means at B we have 4 tokens. 1, 2, 3, 4. 4 tokens. Now 4 tokens means B execute 2 times. B fires twice. B fires twice. So when it fires twice, it will be firing for 2 times. So 2 times, 2 tokens will be generated. So tokens 2 times will be generated. 1, 2, 3, 4. Now in the feedback, no tokens are there, but these 4 will go here. Again, it starts from the beginning. Okay. So did you get this? So what I was just conveying, did you understand this? Hello, anybody?
Yes, sir.
Okay. So the logic here is we have 4 tokens in the feedback, and the first time in the feedback initial token is given, A needs 3. So 3 will be generated. So maybe I will just write down like this. So A, B, and the feedback. So iteration 1. Iteration 1. Okay. So under A, when A fires, 3 tokens input and 3 tokens output. Okay. So now in the feedback we have initial, sorry. So we have initial tokens. So initial token totally 4 tokens. 1, 2, 3 and 4. A has input 0 first initially, output, and the input for B and output for B. Okay. So no token initially. So this is the first one. Then the second iteration, iteration number 1. Iteration number 1. So input 3 tokens. 1, 2, 3 tokens. So output also 3 tokens. So B null. Here it will be only 1 token because the 3 tokens is consumed. So totally it has only 1 token. So in the B here input, so this among these 3, the output it will be 2 will be consumed, 1 and 2. So this one in buffer. So 2 will be consumed here. So in the output it produces 2. The output. Okay. So this is an input and this is an output. Okay. So this iteration number. So iteration 2. So the iteration 2 again these 2 when it joins here, so this iteration number this becomes 3 here because these 2 will move here, it becomes 3. Okay. Now this 3 comes here in iteration number 2. This 3 comes here. Then output also these 3 will be here. So then here this will be 2, and output also will be 2, and we have 4 output because already there is one buffer and these 3. So 1 plus 3 will be 4. So totally 4. So then fires 2 times. So then it goes to feedback as 4. 1, 2, 3. So totally we have 4 things. So will be feedback. Goes as feedback. Okay. So goes as feedback. Then again the iteration rotates. Okay. So this is how the way the SDF also has a feedback. So SDF is synchronous data flow. So mainly suitable for some of the applications. So applications of SDF. So mainly suitable for signal processing application. Then spectrum based application. Spectrum based application. Then frequency modulation. Audio processing. Audio, video, image processing. So these kind of applications, only this synchronous data flow is suitable for. So that's why when we see some examples, so we have seen all the examples related to signal processing applications. So mainly applications of SDF mainly deal with this, because all these things needs frequency, as timing is not important. As timing is not important. So this is about synchronous data flow.